Hi everybody, and welcome back to another lesson with Mrs. John. So today's lesson is going to be looking at work. Okay, so you might wonder, this whole topic is on energy, and so what does work have to do with energy? So if we just think back, the definition of energy is the ability or the capacity to do work. Okay, so you need energy in order to do work. And the nice thing is, how much ever work you've done is actually equal to the energy that's been changed. And also, in order to change energy from one form to the other, like if you're going to lift something up from the ground, you're going to change the kinetic energy when you're lifting it up and you're taking it up, it's going to gain gravitational potential energy, right? Okay, so you're changing energy from kinetic to gravitational, but in order to make that happen, you actually have to do work in lifting it up. And how do you calculate the work? Now, the formula for work is force times distance moved in the direction of the force and the direction of the distance need to be the same. So in year 11, it's all the same, okay? And so first of all, I'll write down how do you calculate work, and then I'll also tell you that whenever you change energy from one form to the other, you need to do work. And therefore, the unit in which work is done is equal to the unit in which energy is measured. So they're both measured in joules. Okay, so how do you calculate work? Work is equal to force times distance, and this is given in words, but on a formula sheet the way that you get is work is force multiplied by distance. That's how you so F stands for the force, D stands for the distance. Okay, and the connection between energy and work is whenever energy is changed from one form to the other, work needs to be done. And the thing to remember is that work done is the same as the energy change. The numbers are the same. You don't have to calculate again. Okay? So that's the most important thing. And also that the unit of work is the joules. Same as the unit of energy, and the symbol is J. All right, so that's the content, and let's look at solving some problems on work. So the problems are on the next page, and there are 7 questions. Maybe we can divide this into 2 halves. Maybe the first day you can do 4 questions, and then the next day we can do the other 3. So split that into 2, okay? And if you have got some leftover work from the previous one, because the last 2 questions were a bit longer, you can kind of have time to catch up on this as well, okay? Right, let's look at this. We just do 3 questions for today, and then we leave the other 3 for the next lesson. So I'm just going to split this up into 2. So here's a question, and this is on page 6 in your booklets, and the title is work. So an apple of mass 0.150, so I'm just going to write the mass of the apple, kilograms, falls 1.4 meters from a tree to the ground. So the height of the tree is 1.4 meters, and it falls to the ground. And then it says friction with the air causes a force of 0.20 newtons. Right, so what energy changes take place as the apple falls? And I'm going to write this in the form of an energy transformation equation, because I think that's really important to remember. So what actually happens is gravitational potential energy, because the apple is at a height, is now converted to 2 forms. So one form is kinetic energy because it's falling, And then you know about friction, so that means some of the energy has been converted to heat. Okay, so the total energy is the same. Right, now calculate the gravitational potential energy lost by the apple as it falls. So GPE is gravitational potential energy lost. The formula is m times g times h. So your mass is 0.150, my g is 10, and my height is 1.4. So when I put all that into my calculator, I'm going to get 2.1 joules. Okay, so that's the answer to that. And then C, use work equals force times distance to calculate the work done by friction to produce heat as the apple falls. So work is force times distance, so this dot also means times. Okay, just another way of writing it. So my force is 0.20, distance at this time is the height, so it's 1.4 meters. So I'm going to get 0.28 joules. Okay, so some of the energy has been lost as heat because of friction. And then the last part is, so the remaining energy is all going to be kinetic. And how much of kinetic energy does the apple gain? So the total energy is 2.1. A little bit of it, 0.28, is lost as heat. So the remaining will have to be kinetic energy, right? So kinetic energy gained is equal to 2.1 minus 0.28, and I'm going to get 1.82 joules. Okay, so those are my answers for this one. So here are all my answers. And this 1.82 can be written as 1.8 joules, just two significant figures. So I hope that made sense, and I hope you can work your way through questions 1 to 3 in this booklet. Okay, so bye for now.